Hello, my name is Brian Dehn. This video is part of my master's project for San Jose State University and my Master's of Music Education. I hope you enjoy it, and if you have any comments or suggestions, I look forward to answering them as we learn about this together. My contact information is at the end of this video. I encourage you to read the accompanying paper first and then come to these videos. So, for our second video, we will dive into Pythagorean tuning and introduce just intonation. As we mentioned in the last video, tuning was just like counterpoint, compositional techniques, tastes, and preferences. They were ever evolving. But as we like to do, we like to compartmentalize. And when appropriate, it is very helpful. So these analyses will be completely different from our typical score study, as they will focus on concepts such as tetrachords and hexachords, which are purely melodic concepts, and an introduction to the lattice, which are tendencies that are, well, frankly, centuries out of fashion. These analyses will not show songs in a key or even a mode, which are compositional techniques, but instead focus on analysis that results in the best tuning of the vocal instrument and its natural tendencies. We already know about equal temperament. Let's now start at the beginning of Pythagorean tuning. This, of course, starts with Pythagoras of Samos. Most know him as a mathematician. Now, Matthew says that Pythagoras and other philosophers like him thought music was not so much an expressive art, but as a kind of audible mirror of an ideal world. How Pythagoras discovered his concept of intervals and his pure ratio scale, which we will talk about, is a great story. So here we have Pythagoras, the famous ancient Greek mathematician, scientist, and philosopher. He lived in a time unencumbered by machinery. Cars weren't invented, horns, or heavy construction as we know. Of course, there was noise, but most of it was produced by human hands. The sounds of nature were predominant, and physics of the natural world prevailed. Pythagoras was also a listener, and he certainly did listen. So this story involves Pythagoras around 550 BC walking around his city-state, hearing a hammer beating a piece of metal on an anvil, and realized that the pitches were different. He saw that it was mostly the length of metal that resulted in changing pitches. He tested this out with different lengths of metal and wanted to measure the lengths. And the stroke of genius led him to determine that ratios were exactly related to pitch. So he finds that the octave was simply a ratio of 2:1. A piece of metal that was twice as long was an octave lower. Then he took strings and found the same thing was true. A string twice as long produced an octave lower. To go another octave, he had to double it again. He was now at 4 times the original string. But what about just 3 times the original length? Well, he tried that and ended up bringing him to the perfect fifth. Ancient Greeks loved the perfect fifth. It was certainly naturally occurring, and it was the only other interval deemed consonant at the time. In fact, it's the third partial or second harmonic or overtone. This is how brass pitches work, for example, accessing those upper partials as harmonics, as harmonics known by string players. So to take it down an octave, Pythagoras takes the G, brings it down so it's just the G a fifth above C. He simply divides by 2, which gave him the ratio of 3:2, and that was his ratio of the fifth that he loved so much. As you read in the accompanying paper, using this 3:2 ideal, Pythagoras logically filled in an entire scale by using the consonant or perfect fifth built up as they make up what we now know as our current chromatic scale. So here we have it, right? C, G, D, A, E, B, F sharp, C sharp, G sharp, D sharp, A sharp, then E sharp and B sharp. Now this is a very important step. Pythagorean tuning is completely based on intervals of the fifth. as they are naturally occurring overtones. We see that the overtone relationship between pitches never quite produces an entire diatonic octave, C to C. Bringing that same graphic up, we see that we get E sharp, not F, and you will notice that it ends with B sharp and not C. See, for centuries, these were understood to be different. In the accompanying paper, I show how mathematically a fifth will never equal an octave. Pythagoras, of course, knew of this error, which is why I discussed the comma, or what he called a Wolf interval. But let us return to the concept of ratios. Here is the entire chromatic scale, as we want to see it nowadays, but in Pythagorean ratios. So you can see the G is a 3:2 ratio, D is 9:8, A 27:16, and gets progressively more complex until we come back around where to the F is 4/3 and the C is 2/1. Now, I love this chart, understanding that the most consonant intervals are the simplest ratios. We can see what we can hear. The most complex ratios are the most harmonically weak intervals. The dominant and the subdominant are the most consonant, right? The G is 3/2, F is 4/3. But conversely, the tritone is the most unstable, 729/512. If we line up our scale chromatically and combine it with the concepts of sense, when we have to do some rounding, but we can really see how different the two, Pythagorean and equal temperament, are when it comes to intervals. This is essentially a simple concept. The Pythagorean fifth is very close to the equal tempered fifth, just 2 cents up. But when singing a third, you must sing 8 cents sharper than the piano. When singing an F, you must sing 2 cents flat of the piano's F. These may seem like small steps, but they add up in a piece just a few bars long, as we'll see later. It would be appropriate to introduce the concept of the tetrachord at this point. The tetrachord is a scale with 4 notes, ut, re, mi, fa, and then we arrive at sol. We have since replaced ut with do. The tetrachord is only 4 notes, and after a few hundred years we wanted a larger range, so we expanded to the hexachord, up to la. An octave as we know it now is do, re, mi, fa, sol, la, ti, do, but this didn't exist at the time. However, looking at it, we notice our half steps between mi and fa and ti and do. But where did this come from? Well, the octave came from simply stacking a tetrachord on top of each other. Do, re, mi, fa, then do, re, mi, fa. This is imperative when it comes to tuning because we need to stay with this ideal of pitch relationships and pitches rarely being more than a sixth away from a center. We should consider scales always being based on a hexachord and its root. This should hold true forever. There are no sevenths or augmented sixths or tritones. You need to just switch the hexachord. The further you move from a tonal center, practical experience tells us, the harder it is to stay in tune. So use a system that helps you stay centered. And the centerpiece of a tetrachord, and a hexachord quite literally, is something that you may have heard before, the mi-fa relationship. This relationship is of paramount importance and quite simple. To know what the tetrachord or hexachord you are in, simply find that mi-fa relationship and then work down to do. It's that half-step relationship that we're looking for. When the half-step changes, you mutate to a new do. So if you see this half-step relationship, let's picture, say, an E to an F. Well, then you're in a C hexachord. If you see this half-step relationship, say, A to B flat, well, then you're in an F hexachord. Included in the paper is a handout that I use when introducing hexachordal mutations to high school age students. I also address it in my next video. But now let's apply it to a chant. So here we have Ubi Caritas. This is one of my favorite chants. Okay? Ubi Caritas et amor. Deus ibi est. So now let's input our solfege that we all know and understand. Do, do, re, mi, fa, mi, re. Do, do, re. So what we have to do is not tune this with equal tempered sense, but Pythagorean sense. So remember that the re is actually 4 cents higher and the mi is 8 cents higher, right? So here's what it looks like. So now you can see that the re and the mi have to go up, but the fa has to be a little under. So it's different as opposed to do, do, re, mi, fa, mi, re. But that's wrong. It's do, do, re, mi, fa, mi, re. Do, do, re. Is much brighter than do, re, which is in tune with the piano. So you can see how it changes between our equal tempered ears and a true hexachordal Pythagorean tuning. There are a few sets of rules that tend to emerge. The fa is down 2, a mi is up 8, re is up 4. We never get to it, but a sol would be up 2 and a la would be up 6. If you go pitch by pitch without adjusting to Pythagorean tuning, the above line alone can result in about 50 cents flat, which is a quarter of a tone, by the end of this first line. Ever wonder how choirs go out of tune so quickly on unison lines? It's because often the director is hearing equal temperament, and the human voice is more comfortable producing this more natural tuning. It behooves us to know where to ask for a little bit more focus, and this is where conducting comes into play, which I'll explore in the final video in this series. Let's move on to Te Lucis. I like this motet because it starts with an existing chant and uses that pre-existent material, as was typical of the time, as the basis for the motet. So here we would first look at it as A minor, right, as the key. But as we need to reiterate, our concept is not so much about the compositional or modal techniques, but the tuning concepts. So saying that we need to do A minor, Mixolydian, or a Dorian, and then back again are simply not accurate, nor do they help us tune. When we do a hexachordal analysis, the piece comes alive with all kinds of harmonic fireworks. This is now a good time to introduce just intonation, and more specifically, 5-limit just intonation. I go into the math of it in my paper, but Pythagorean tuning, which we already discussed, is actually a form of just intonation, but it's known as 3-limit just intonation. But as we progressed to liking thirds and treating them as a harmonic consonance as opposed to dissonance, we have to think back to our studies of writings of Zarlino, or even more practically, the English countenance or the guys, right? We needed different ratios to work. The third is also a naturally occurring overtone. So instead of stopping at that third partial, we now want to go to the 5th partial. The naturally occurring third is now a ratio of 5:4. And not the 81:64 that Pythagoras preferred. This changes up our ratios a little bit, which I'll explain in the next video. But here's a new chart with all 3 in sense. The 3-limit Pythagorean tuning, we have our changes, right, from equal temperament. The re was up 4, mi was up 8, fa was down 2, so was up 2, la was up 6. But with 5-limit, we have 2 pretty major changes, right? Mi is now down 14 cents from equal temperament. That's a swing of 22 cents. And la is down 16 cents, which is also our 22 cents, which is something that I love because it's the same size as Pythagoras' wolf interval, or that comma that he found earlier. But how do we use this? Well, this is what takes the most time for a director. And Matthew's book is the only thing I have found that teaches you how to hear. I have found success allowing my group's natural fifth to dominate. We simply have this discussion. But I do a hexachordal analysis beforehand. Show them mutating wherever the mi-fa relationships tells us, and then use drones underneath to modify what I want to hear. There are chapters in this book by Matthew on how to hear different just intonation thirds, but I have found that most people can hear it when they trust themselves. You play the line with a drone, right? Just one note from the piano, or you could even add that fifth because it's close enough, just 2 cents different. But as a director, you need to hear in your head what you want to hear from the choir, or what I always say, hear what you want to hear. So let's go back to the Te Lucis with our hexachordal analysis. There are a few things we can look here. The first one is that opening chant, right? Bar 1. The hexachord is actually based on G, okay? So as opposed to A minor, Te lucis ante terminum rerum creator poscimus, we actually need to tune it to a G, right? Te lucis ante terminum rerum creator. Now then in bar 2, we actually have to make a switch here. And there's 2 options. We'd either do mi, re, do, or we could do, right? We could do la, so, fa if we were in C. La, so, fa. You could do that as well. Now, you have to picture the F hexachord, and then you have to picture the C hexachord. And you just reassign it or retonicize it based off the new pitch of the do, because again, you're focusing on that mi-fa relationship. Now, I think compositionally we have a clue later as to which one to choose. I think it's the tenor in bar 5, but I'm going to choose an F, which gives me that brighter A. That mi is brighter than the la. So I hear Te lucis ante terminum rerum creator poscimus, as opposed to Te lucis ante terminum rerum creator poscimus. Either one could work, we just have to make sense. Okay, we have sense of it. So now in bar 4, we kind of have the same issue. I think it should be the same. Again, I like the F, but again, this is also because of something happens later, right? Ut solita clementia sis presul ad custodiam, right? So now let's go to the actual motet section, right? So the alto 1 line, or that second soprano line, I usually split the choirs when I do this. Bar 2, 3, and 4 for that line is just great, right? Procure cedanso, but again, it's based on the C. Procure cedanso nia. It modulates to an A hexachord. Okay? Now, bar 2, we have this bass line, right? Right? So if you're in A minor, that's going to be crazy to try to tune that. But if you just tune it that hexachord, right? Procure, and then it changes. Cedanso, then and that will tune much better. Bar 5, we have the tenor line, or that second alto. That C really does make for a nice like tonal fulcrum. So if that second female part, right, that second part down is having issues, then perhaps you need to have them tuned to that, even the tenors, to be that C. But what I like doing is because the tenor is right here, right, I think it's more based off the G, and that's a fa, right? Phantasma, and then it switches to ta, goes up to C, okay? So the top tenor line and the bass line, I'm talking about bar 6 now, that last C will move up 4 cents. I think it makes sense to change to an F there because of the chord that we hear. But then also that next phrase, they're also in the new hexachord. Let's look at bar 7. We have another great bass transition, right? Nostrum comprime, but we tune it on Nostrum comprime, right? And then in bar 10, you have that tenor 2 part. There's another fun choice, is when to switch to that G hexachord. Do you want to switch it on the G or the A? And there's really no difference as far as pitch, but it might make more sense to do it on a beat. There are a few other mutations that occur, but this is a good start. So our next video will dive more into the theory behind 5-limit just intonation, which is most of what our choral music is in, and how to apply it a little more. I'll see you on the next video.